Good morning, sir. Myself B. Rajeshwari, currently pursuing third BTech in Srinivasa Ramanujam Institute of Technology, a specific branch of Electronics and Communication Engineering. According to CA2 video presentation, the topic is the uniform linear arrays. The subject is the antennas and wave propagation. The subject code 23ECE502. The topic is a uniform linear arrays. Introduction of the uniform linear arrays. Uniform linear arrays ULAs are the type of antenna arrays with the elements of the spaces of the equally along the straight lines. They are wide used in arrays of the signal processing, radars and wireless communication. Understanding ULAs are the essential beam formings and the directions and the spiritual of the filtering and applications. The basic concepts of ULAs. The ULAs consist of the n antenna elements arranged within a uniform spacing D. The array geometries, influences of the radius pattern and the direction of the propagations. The key parameters of the included elements of a spacing, number of elements and the operating wavelengths. The uniform linear arrays in an isotropic point sources is the equal amplitude of the spacing. Let us proceed the case of an isotropic point source of equal amplitude and the spacing arranged in a linear arrays in the instant of the figure 1 when n is in any position integrator. Psi is equals to the figure over there arranging the linear array of the n isotropic points. The total field of the E at the larger distances in the directions of the psi is given is E is equals to 1 plus E j psi 1 plus E j2 psi E j3 psi plus E j n minus 1 psi, where psi is the total phase differences of the fields from adjacent sources as the different given by psi is equals to 2 pi d by lambda, cos pi is equals to dr cos pi and rho. Multiply 1 by the E j psi gives to now subtracting the equation over there, and E is equals to 1 minus E j n omega j n psi and 1 minus E j psi. Equation 4 may be rewritten E is equals to E j n psi by 2 E j psi by 2. E j n psi by 2 minus E j n minus j n psi by 2 E j psi by 2 minus E minus j psi by 2. For this equation, this is the final equation over there. The value of epsilon is given by epsilon is equals to n minus 1 by 2 omega psi. If the phase of the interferences on the central points on the arrays, the equation 6 becomes E is equals to sin n omega by 2 sin n psi by 2 sin psi by 2. The principle of the maximum occurs when antenna of the element. The radiant is a phase leading at the maximum constraints of the interference. This happens when psi is equals to 0, when psi is equals to 0. Equation 6 or 8 is a intermediate, numerator and a denominator both tends in 0. So that for this case E must be obtained as a limit equations of the 8, psi is approaching 0. Thus for a psi is equals to 0, by using in a L hospital rules, we have relation that E is equals to n. These are the maximum values of E can attain, hence normalizing values of the total field. For the E max is equals to n is equals to the field of the given equation 9. We will references as the array factor. We may conclude from the above discussions that is the field of the array will be a maximum in any direction psi. For which way the psi is equals to 0. Started in another way, the fields from sources all arrived in a distant points in a same phase. When psi is equals to 0, in special cases psi may not be a 0 for any value of psi. And this case the field of the usually is a maximum and a minimum values of the psi. These are the applications of ULA. ULAs are used in a direction arrivals DOA estimate in the radar sonar and systems. They enable spatial filtrations of the improve signal qualities and interference suppressions. ULS is integrated in adapted beam forming and a MIMO communication system. These are the advantages. ULS offers in a simple design and a straightforward mathematical analysis. They can be easy scaled to accommodate and different number of elements. They predict a pattern, make a suitable for various high resolution and sensing applications. These are the limitations and challenges. Grating lobes and mutual couplings effects can be degraded in array performances. Precious elements placement and collaborations are requirement for the optimal operations. Physical size and the cost can be become a significant with increases the element numbers. Thank you.